So let's see how to find sample size, okay? Let's see how to find sample size for large sample and for confidence interval in proportion, okay? So let's take these two examples. Now for example 1, it says a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From previous study, the standard deviation of the depth measured was 4.33 feet. How large a sample size will be needed? Okay, how large a sample size will be needed? Now, you'll be thinking, to find sample size, there are 3 different or 4 different formulas for it, depending on the type of question it is. For the question 1, let me give you 2 possible ones that are likely to go for it. Okay, then I'll tell you the exact one you will use. The formula says pardon me for the way I've written it, Z alpha over 2 multiplying standard deviation divided by E is called margin of error, okay, divided by E all squared, or there is one also we use as N is equal to T alpha over 2 okay, comma N multiplying standard deviation divided by E divided by E all squared. Now, we are to use either of these two for question 1. But you'll be wondering, which should we use? The fact is, for question 1, we are going to use this one. The reason is, when you look at the standard deviation you are given, it's not a sample standard deviation, it's a population standard deviation. It says from previous study. This statement, from previous studies, it shows that this standard deviation is not coming from the sample that you've taken. It is coming from previous studies. So it's population standard deviation. So since it's a population standard deviation, we use Z. Okay, we use Z. So in that case, to find N will be equal to, so we substitute Z for. Now, when you are 99% confident, your Z score will be 2.58. Okay, you have to know that. Or 2.578, which is 2.58 when you take it to 2 decimal places. So 2.58. 2.58. 2.58. 2.58. Okay. Times. What is the standard deviation? The standard deviation says what? 4.33, isn't it? So 4.33. 4.33. 4.33. 4.33. Okay. Let me put the points properly. Points. Okay. Divided by, what is the error? Wherever you see a statement like this, within 2 feet, within 2 feet, within 2 feet. That's the margin of error. Okay, so the margin of error is 2. E is called margin of error. Then all squared. All squared. So it will give you what? When you fix this on your calculator, you get 31.2. 31.2. Get 31.2. Now, when you get something like that, you need to round it upward. You need to round it up. When you round it up to the top, okay, that will be 32. Though you'll be thinking that 31.2 into whole number is 31, but like you have to round it upwards to 32. Okay, so your answer is what? Is 32. So 32 sample size would be what? Would be necessary. Okay. Then to solve the question 2. Now for the question 2, they say a researcher wishes to estimate the percentage of M&Ms that are brown. He wants to be 95% confident and be accurate within 3% of the true proportion. How large sample size would be necessary? Okay, how large sample size would be necessary? To do this, you realize that there's nothing like mean, nothing like standard deviation here. So you should know it's a proportion because you can see even the error is in percentage. So, and the question even said it over there, true proportion. So it's a proportion one. So the formula for the proportion one doesn't go like this straightforward. This is how the formula goes. The formula says N is equal to P hat times Q hat times Q hat times Q hat multiplying Z multiplying Z multiplying the Z. Okay, multiplying Z divided by error the margin of error, we call it margin of error, okay, divided by the margin of error square. Now this square is affecting only what is in the bracket. It's not affecting the P hat and the Q hat. Okay, it's not affecting the P hat and the Q hat. So this will give us what? When we do substitution. Now, when you look at the question, you realize that we only have Z, the 95% to give us the Z, and we have the margin of error, but we don't have the P hat and the Q hat, isn't it? So if you have a question that looks like this, you consider your P hat and Q hat to have equal like share, as in 0.5, 0.5. So P hat will be 0.5 and Q hat will be 0.5. But if the question gives you the P hat, you use the right thing. If the question gives you the P hat as, let's say, 40%, that's 0.4. You subtract 0.4 from 1 to get Q hat, isn't it? But if you have a question like this particular one here that hasn't given you the P hat and the Q hat, you use your P hat at 0.5 and use the Q hat at 0.5. Okay, 0.5 times 0.5. Okay, 0.5 times 0.5 times, then you open a bracket. Now, when you are 95% confident, your z-score should be 1.96. Okay, when you are 95% confident, in confidence interval only, okay, when you are 95% confidence, your z-score should be what? 1.96. 1.96 divided by, what is the error? It says within 3%, within 3%, meaning your error is what? 0.03. 3% in decimal means 3 divided by 100, which is 0.03. So 0.03. 0.03. Okay, before you square. When you fix all this on your calculator, 0.5 times 0.5 times into bracket 1.96 divided by 0.03 all square, you should get what? 1067.1. Okay, 1067.1 67 1067, sorry, sorry, point one. Okay, I'm not using the right machine, so kindly correct that for me in your own book when you are rewriting. Okay, so 1067.1. Okay, 1067.1. Okay, let me do like this. Let me do it like this. 1061 points. Let me rewrite. 1067.1. So 7.1. But you have to round it up, okay, like how you did the first one. So it will become 1068. 1068. 068. 1068. So that's your final answer for this. Okay. So when you see question on finding the sample size or whatever, this is how to do it. Okay. Thank you for watching.